All right. So these are part of the Pikeville Roboteers team, which is kind of the term we've given our students who work with robotics. They're in 6th grade. We have started a STEAM initiative a couple years ago, and it's kind of slowly built, but they are exposed to dash and dot robots in 5th grade, some other coding and skills throughout their technology class, and then in 6th grade they get to work with the Lego EV3 robots. And so my problem of practice was that I feel like that kids need more with the engineering design process. So with the new NGSS standards, of course, that's kind of hitting the engineering design process, but it's also really great just to get them to be persistent and have grit and problem solving. Because with that process, they have to persevere. They're given a problem, and then they're going to come up with a design for it or a solution, and then they're going to test that, and if it doesn't work, then they're going to go back to the drawing board and find a different idea, and then keep testing it until it does work. So there isn't an I don't know how to do this, or it's not working. They have to learn to keep going in that cycle until they get it right. So we saw that we were seeing students who just wanted to kind of hit the wall, not go on, and so my thought was that robotics is a great way to get that persistence and grit in their problem solving. So my hypothesis was teaching computational thinking through building and coding robots will help students develop that perseverance and grit in problem solving. And this was kind of our flow whenever we were designing and building robots. We had a challenge or a goal for that. They would explore it, see what other people did, come up with their own designs, then create it, try it out, make it better. And you're going to hear from them in a minute about that process. So with the addition, we already had 2 robots, and this grant allowed us to buy 2 more and some extra pieces. So in the fall, they just had the 2 robots, and we played around with the Lego League robotics. And then with the 4, we decided we're going to do Sumo Bots, which is an STLP competition that they will be going to Thursday. So that allowed them to have 4 groups. So who wants to talk a little bit about how having 4 robots versus 2 is a big impact?
So before we had 4 robots, we had 2, as Ms. Scott said, and it was very hard. We were split off into 2 groups, kind of. It was a boys and a girls robot. She didn't decide that, we did. And the boys, they kind of didn't work well together. They would get mad at each other very easily. So this grant has helped our cooperation a lot, and it's helped us learn more individually than together, so we can actually know what we're doing. You want to talk?
I think having the 4 robots is very important because when we only had 2 robots, there was a lot of competing minds, and that made it a lot harder to get the overall design that we desired. So having the 4 robots helped us actually be able to inflict on what we know and show how we can do, show what we can do and show what we can build and program. I'm loud enough.
Okay, so how many of you didn't code the first semester, but you got to code the second semester? Okay, and then, there was more of them. There's 6 other ones that aren't here with us today. But the big thing was that they each got to really feel like a part of it with the extra robots instead of kind of just designing, collaborating all together with 5 and then one person kind of taking the lead. Each of you all have had your turn deciding what goes on with the robot and what's better and what's not better. So Sumo Bots, what Sumo Bots are is they're designing a robot. This is one of them. So there's 4 groups, each had their own design, and the goal is that they compete in a ring, and you have to push the robot out or disable the robot, and then you win the match. So the first thing they did was they looked at, in the engineering design process, you explore and you design. So they looked at what other people have put out there, last year's robots, and then things that are on YouTube for Sumo Bots, and then they kind of put together their own little wish list of what they thought their robot needed to look like. And then they started to create them. So this was these two girls' robots. It's not the winning robot, however. But we had a competition last night. But is this how your robot started? Did it always look like this? No. Okay. So you want to talk a little bit about that design process?
So it was very small at first. And we had seen videos on YouTube how other people had built their robots and how they fought. And we decided, hey, that's a really good idea. We should use it. And we took a lot of inspiration from that. And then Miss Scott also gave us a lot of inspiration too on how we should do it. Yeah. You want to talk?
How did you all decide ultimately to get the wall?
Okay. She's making me talk about this because I built it. The wall, our wires kept getting pulled out, so we decided we need something to protect that. So we built a wall, and now it really protects it. So.
Okay, so they would have these test trials, which is part of the whole creating and testing, right? So they would battle each other, and so their group, their wires kept getting pulled out, or they kept getting tangled up with the wires. So that's where their wall design ended up coming in, and then they first had a back wall to like push, and then they had the side wall to help. So that's that whole like figuring it out, what works, what doesn't work, how it's going to change or not. And then in their coding, as you can see, this is pretty advanced coding, especially for the sixth graders. We're dealing with loops and switches. So once they set the robot down, it has to be able to do its own thing. They don't get to touch it. So once they hit start, it's all relying on sensors. So these will see the robot. This is the color sensor. You can, if something bumps it. So they've designed a code for it to be able to hit all these different variables. So that took a lot of planning too, right? How many times did you all have to change your code? A lot of times to get those sensors right, to figure out what works best in the ring, that sort of thing. So we had our final showdown at STEAM Night last night at Pikeville Elementary. It was a double elimination tournament to kind of simulate the state tournament because we can only send one robot to state. And that was a great time. Did you all have a good time? Yes. And our winning robot was not the one we thought would win. We all thought Drew's was going to win. And so we have a winner. So what I saw was that they went from being very frustrated in the beginning and wanting me to tell them everything to do, and I can't because I don't know how to do it myself. And now they are very persistent in problem solving, right? So what do you all think is the most beneficial into the classroom out of these robots?
Not having to like compete with other people and not having to share and persevering and being able to apply what we learned in GT to out of GT. Thanks.
Yeah, so they have definitely become better problem solvers and more persistent. Thank you all.